Hi everyone, my name is Omar Khan. The title of our paper is Influence of Avatar Appearance and Target Distance on Locomotion Method Selection in Virtual Reality. And I'm happy to be presenting this on behalf of my co-authors Junyeong, Dr. Hyeongil, Dr. Myungho Lee, and Dr. Kangsoo Kim. I'll start off this presentation with a brief introduction. So in VR apps and games, users are often given options for their locomotion method. But prior to the current work, there was a literature gap on what factors would influence users' choice of locomotion, and this is knowledge that's very useful to VR developers and designers. In this paper, we're focused on how avatar appearance influences locomotion preferences. There is previous research in line with this, such as embodying a gorilla changes users' locomotion preferences, or embodying an elderly person changes the user's walking speed. But prior to the current work, no one has investigated how it influences the decision to either teleport or physically walk when users are given the option of doing one or the other. So our research questions are: 1, how do various dimensions of avatar appearance influence users' locomotion method selection? And 2, how does target distance influence users' locomotion method selection? On to the methods. We conducted an experiment with a 2x2x2 within subject study design with 3 independent variables and 2 levels for each. The first was body weight, which could be either normal or obese. The second was clothing, which could be either casual or a superhero outfit. And the third was body completeness, which could be either full body or upper body only. For our implementation, we used Unity as our game engine, MetaQuest 3 with AirLink as our head-mounted display, Ready Player Me for our avatars, which were customized by each participant, and we ran the study in this 5x5 meter room to give enough space for natural walking. During the experiment, we randomized the order for the distances at which the target would appear, and we included 3 distance values: 1.5 meters, 3 meters, and 4.5 meters. The participants could choose to either physically walk or teleport to the targets in the scene. We recruited 24 participants. Here's the gender distribution and the age distribution, and none of the participants had physical or sensory impairments that we found would detract from the results. And the participants had varying prior VR experience, and you can refer to our paper for more details on that. Our measures included willingness to walk, which we wrote a custom questionnaire for. To ensure our questionnaire was reliable, we computed Cronbach's alpha values, for which it showed good internal consistency. We also included the percent of targets that the users teleported to instead of physically walking to as an objective measurement. And we also took questionnaire data on perceived resemblance to the avatars, as well as the virtual embodiment questionnaire, in case we'd find any interesting findings there. Our hypotheses, based on prior research, were that participants embodying full body, non-obese, and casually dressed avatars would be more willing to walk than those embodying upper body only avatars, or obese avatars, or superhero armored avatars. And additionally, for our second research question regarding target distance, our hypothesis was that users would walk more to targets located closer to them and would teleport more to targets located further from them. To analyze the results, we ran repeated measure ANOVA tests at a 95% confidence interval, and all of the assumptions for the tests were met. Our test revealed a significant interaction effect between avatar body weight and avatar completeness. As you can see in the bar graph, participants embodying normal weight avatars were significantly more willing to walk than those embodying obese avatars, which matched our hypothesis. However, interestingly, this effect was only observed for full body avatars, not upper body only avatars. hence the interaction. Additionally, there was a significant main effect of target distance on the percent of targets teleported to. As you can see, there is a significant difference between 1.5 meters and the other distance values, but no significant difference between 3 meters and 4.5 meters. For the participants' perceived resemblance to their avatars, we found a main effect of body weight, for which the normally weighted avatars scored greater than the obese avatars, which makes sense because most of the population is not obese. And we also saw an interaction effect, which says that when clothing was casual, full body avatars were perceived to resemble the participants more than upper body only avatars. We also saw significant effects across the board for embodiment. Participants felt greater body ownership when their avatars were normal weight and when their avatars wore casual clothing. Interestingly, participants felt greater agency over obese avatars than they did for normal weight avatars. We don't have an explanation for this in this paper. It could possibly be a chance finding, but it's a potential area for future embodiment studies to explore. And there was a three-way interaction for perceived change in body schema. And you can read the paper for more details on these, but it makes sense because the body schema did change significantly across all of the avatars. We also ran an exploratory correlation analysis, and I'll go more into detail on this in the discussion, but here's a table with all of the significant correlations. And you can see that there were several conditions in which perceived resemblance to the avatars correlated with willingness to walk. Now we'll move into our discussion and talk about our key findings. Based on our observed interaction effect between avatar body weight and avatar body completeness, we conclude that avatar obesity decreases willingness to walk, but only for full body avatars, not for half body avatars. We included a participant quote which reflects this finding. Participant 16 said, "With the obese characters, I suddenly felt like it was too much work to move around." This matches with our hypotheses with some nuance considering the observed interaction. Our second finding, based on the main effect of target distance, is that close targets promote walking more than far targets, up to a certain threshold distance, and that threshold is somewhere between 3 meters and 4.5 meters. Participant 13 commented that when the mirrors were very close to them, it felt more natural just to step towards it. Our third key finding is that users' perceived similarity to their avatars is positively correlated with their willingness to walk. And a participant quote which captures this well is from participant 13, who said, "I didn't mind walking because I wanted to take a better look at myself. If something looks like me, I'm more likely to want to take a closer look and look at myself for longer." Now I'll really briefly touch on some implications of our findings. Firstly, developers may have certain constraints for their applications or games, and they may be able to use our findings to influence their users to walk more or teleport more in accordance with their desired user behavior. Secondly, our findings can encourage users to walk more in VR for health benefits. Sedentary behavior is detrimental to health, so as people spend more time in VR, especially children, our findings can be applied to encourage healthy movement in VR games and social VR applications. Lastly, we had an interesting interaction effect between avatar completeness and avatar body weight, which opens up new questions on the Proteus effect, which future work could possibly explore. Thank you for viewing our presentation, and if you have more questions, you can refer to our paper, which includes more details.